Effect of Multi-walled Carbon Nanotube Incorporation on mechanical properties of concrete with partial replacement of cement with fly ash. Carbon nanotube incorporation in the various existing materials is gaining more interest among the material science researcher in past few decades. This situation is due to the high strength property of the CNT. This paper is based on the research on multi-walled carbon nanotube incorporation in concrete and its effects on the mechanical properties of the concrete with partial replacement of cement with fly ash. The partial replacement of cement with fly ash at 20% in volume was also done. Hence the aim of this research is to study the behavior of normal concrete with multi-walled carbon nanotube and fly ash. Totally, 75 cube specimens, 30 cube specimens, 30 cylinder specimens and 15 prism specimens were casted for this research as 5 sets. The multi-walled carbon nanotubes were incorporated as 0.025%, 0.050% and 0.075% on the weight of the cement in concrete. The dispersion was done by the Poly Carboxylate Ether chemical and magnetic stirring for the effective dispersion of the multi-walled carbon nanotube in concrete. The mechanical tests such as compression test and split tensile test were conducted on the cube specimens, compression testing was conducted on the cylinder specimens and the flexural testing was conducted on the prism specimens. Keywords: concrete, multi-walled carbon nanotubes, fly ash, compression strength, and flexural strength. Introduction. The most important construction material of modern-day construction is concrete. Concrete properties are mostly depends on the various parameters and the constituents which comprises the concrete. The major factors governs the concrete strength are cement property, water-cement ratio, properties of aggregates and so on. The general property of concrete is having high compression load carrying capacity and very low tensile load carrying capacity threefold IJERT. AL 2016, stated that the concrete have significant compressive strength and very low tensile strength. This low tensile strength often leads to the formation of the early cracking in concrete. Hence it is necessary to find a solution which can increase the tensile capacity of the concrete. Literature review. Carbon nanotubes, CNT, are allotropes of carbon. They have a tubular nanostructure with diameter in nanometers. It was observed that it have the largest value of length to the diameter ratio of 132 million. Since these CNTs have significant mechanical, physical, electrical, and chemical properties, it has more attention in the recent past. They are mainly classified as single and multi-walled carbon nanotubes. 7. The carbon nanotubes are the allotropes of carbon which are discovered from fullerene. These nanotubes have the diameter 1 to 4 nm and the length up to 100 nm. The CNT have many significant properties such as few hundred times higher strength than steel, 6 times lighter than steel, high thermal stability etc. From these properties it is concluded that the carbon nanotubes are the strongest man-made material ever generated. These carbon nanotubes are 5 types. They are single-walled carbon nanotubes, multi-walled carbon nanotubes, nanotorus, nanobuds, and polymerist single-walled carbon nanotubes. There are 3 methods of carbon nanotube growth. They are laser ablation, arc discharge, and chemical vapor deposition method. 8. In recent times the carbon nanotube incorporation in materials has gained more interest due to the very high strength of the carbon nanotubes. It was observed that the CNT have effective pores and cracks filling nature which helps as a filler which reduces the pores in concrete and also helps increasing the tensile strength of the concrete. 5. It was observed that the use of nanomaterials such as CNT, nanoclay, titanium oxide, and nanosilica shows a significant increase in the properties of the conventional materials. It was also shown that the utilization of these nanomaterials similar to the use of micromaterials such as metacolin and silica. It increases the strength and durability properties of the mortars and concrete. 7. According to Courson et. al. 2008, the major disadvantage in the cementitious composites is its brittle nature. Due to the brittle nature this leads to the formation and propagation of the cracking in cementitious composites. These cracks sized from micro to macro level. Cold et. al. 2004 stated that there is 12% increase in the concrete which consists of 0.5% of CNT by the weight of cement with the W/C ratio of 0.22, but he found that there was a decrease in the compressive strength of the concrete as 2.5%. Hence he concluded that was not the optimum amount of incorporation to achieve more flexural and compressive strength simultaneously. Courson et. al. 2008 studied the effects of various surface modification in the CNT incorporated concrete. They studied the effects of surface-modified CNTs and normal CNTs for incorporation. The polyacrylic acid and gum arabic chemicals were used for surface modification with ultrasonication. There are totally 3 different sets were made. They are 0.023%, 0.1%, 0.14% with polyacrylic acid as dispersant and 0.023% and 0.1% of CNTs with gum arabic and 0.14%, 0.5% and 0.15% with polyacrylic acid were added with functionalist CNTs. The maximum increase in the compressive strength of the concrete was observed in the 0.045% functionalist CNT with polyacrylic acid as 50%. It also showed a significant increase in the workability and the increase in the properties of concrete based on the amount of CNT incorporation and the dispersant. The study on the effect of CNT incorporation in the articles of Metaxa et al. 2009 stated that there is a significant increase in the properties of the cement matrix flexural strength as 50% and elastic modulus as 25% when the water-cement ratio of the concrete is kept as 0.5. Collins et. AL 2012 studied the CNT incorporation with the various surface modification agents such as polycarboxylate, calcium naphthalene sulfate, lignosulfate, and naphthalene sulfonic acid. It was conducted with the CNT incorporation at 0.5%, 1%, and 2% in the weight of the cement. Among them the specimens with the polycarboxylate showed a significant increase in the compressive strength as 42% than the control mix when the surfactant was added at 0.8%. Hamzawi et. AL 2012 stated the effects of incorporating CNT in cementitious composites by adding 0.004 and 0.004% for concrete and 0.01%, 0.02%, 0.03%, and 0.06% in cement mortar in weight of cement. The maximum increase in compressive strength was obtained from the 0.01% incorporation as 21.2% in mortar and 0.003% showed an increase of 17.65% than the conventional composites. And there was also observed the constant decrease in the strength in the composite on further additions. Hence it was concluded that the optimal amount of CNT incorporation can be done at 0.01% for mortar and 0.003% for concrete. In a study conducted by Haddad et. al. 2013, 3 ratios of CNT incorporation were done. They are 0.2%, 0.4, 0.6% in weight of cement and mortar and conducted mechanical tests. Among the various ratios 0.4% added CNT incorporated mortar showed a significant increase in the mechanical tests. It showed an increase of 40% in compressive testing and 30% in tensile testing and 15% in flexural testing. This was concluded as the optimum value of CNT to be added in a cementitious composite in that study since 0.2% and 0.6% did not show any significant increase in mechanical testing. Re-et. AL 2013 studied the effects of incorporation of CNT in cementitious composite with 0.25%, 0.5%, 0.75%, 1.0%, 1.25%, and 1.5% of CNT in the weight of the cement. The CNTs were treated with surface modification dispersant sodium naphthalene sulfonate formaldehyde solution and Sony cation process. The mechanical tests such as compressive testing, split tensile testing was carried out in the research. The maximum value of increase in compressive strength of the concrete was achieved at the 1.0% incorporation as 40% than the control mix. The split tensile strength was increased at 72% at the same 1.0% incorporation. It also showed less permeability and electrical conductivity in the respective tests. It was observed that there was an increase in the properties in a constant trend from the lower amount to higher amounts. Hence at the inflection point which 1.0% is showed the maximum values and thereafter steep decreases in properties were found. IJERT. AL 2014. Conducted research on effects of multi-walled carbon nanotubes incorporation in cementitious composites. They conducted testing by adding 0.1% of MWCNT with the concrete. The MWCNT was functionalized with ultrasonic energy and incorporated. The mechanical tests such as compressive, flexural, and impact resistance tests were conducted. The increase in the compressive strength and impact resistance were found 58% and 1400% respectively than the control mix. But there was observed only 2% of increase in the flexural strength of the concrete with MWCNT. And they concluded that only small amount of MWCNT shows a significant increase in properties of the cementitious composite. Samchenko et. al. 2014 studied the surface modification of the CNT with poly carboxylate ether during the incorporation in the composite materials. This paper studied the dispersion of CNT with the various surface modification materials such as Metaflux and water. It was observed that the CNT with the poly carboxylate ether showed a significant stabilization. Foldina et. al. 2016 studied the various difficulties in CNT incorporation in cementitious composites. It showed the various dispersion methods such as ultrasonication, chemical dispersion, and some other techniques for dispersion of CNT in the cementitious composites. This paper also explained that the effect of dispersion shows significant results as improvements in the properties of the composites, and less improvement in the poor dispersed composite. Experimental investigation. Casting of specimens. From the above literature study the method of CNT incorporation and amount of incorporation were finalized. Based on the arrived details the multi-walled carbon nanotubes were selected for the incorporation. The polycarboxylate ether solution was used as dispersant. The M30 grade of concrete was selected as control mix. The addition of Class F fly ash was also made partial replacement to study the composite property of the concrete. There were totally 5 mixes. The materials were tested for preliminary tests for arrival of the proper mix design. The water-cement ratio was finalized after the slump tests. The specimens were casted. The property of CNT is shown in the Table 1. Table 2 shows the various mix which are arrived for the research. The Table 3 shows the mixed proportion of the concrete. Surface decoration. Surface decoration of the multi-walled carbon nanotubes plays an important role in the dispersion and the increasing the strength of the CNT incorporated concrete. Hence the surfactant was selected with excessive care. The polycarboxylate ether solution, PCE, was selected for the surface decoration and the surface decoration was done with the help of magnetic stirrer. The CNT was added with the PCE and stirred with the magnetic stirrer for 60 minutes at 600 rpm. This was done to avoid the agglomeration effect on the concrete. Then materials for the casting of the concrete such as cement and aggregates were batched. The OPC 53 grade cement was used for the concrete. All the preliminary arrangements for the casting of the specimens were done. Then the mixing of the concrete was done with the concrete mixer. The casting was done as 5 sets. Each set consists of 6 cubes, 6 cylinders and 3 prisms. After the casting of cubes as 5 sets it was cured for 28 days immersed curing. Then the mechanical tests were conducted. Testing of specimens. The mechanical testing of the cubes and cylinder were done on the compressive testing machine. The flexural testing was conducted in the flexural testing machine. The testing was conducted based on the codal provisions. The figure 1.A-1.D shows the mechanical testing of the specimens. Results and discussions. After the testing of specimens the results were computed based on the conventional procedure. The compressive strength for the cube and cylinder specimens and the split tensile strength for the cube specimens and the flexural strength for the prisms were computed. The figure 2 shows the compressive testing results of cube specimens. Figure 3 shows the compressive testing results of cylinder specimens. Figure 4 shows the split tensile testing results of cube specimens. Figure 5 shows the flexural testing results of prism specimens. Flexural test of prism specimens. From the compression testing of the cube specimens the increase of 29.6% and 7.25% was observed in the 0.075% CNT concrete than the fly ash in conventional concrete respectively was observed. In the cylinder compressive strength testing 5.45% and 22.2% of increase in strength was observed in the 0.075% CNT concrete than the conventional and fly ash concrete respectively. The split tensile testing of the 0.075% CNT concrete showed a 78.78% and 39.64% increase in strength compared to the conventional and fly ash concrete. The flexural testing of the 0.075% CNT concrete showed an increase in strength of 26.76% and 14.02% the fly ash and the conventional concrete respectively. Conclusions. There was found a significant increase in the strength of concrete incorporated with CNT. The increase in the strength was observed as increasing gradually as the amount of CNT increases in the concrete. The 0.075% CNT concrete was observed as the most significant mix as it shows the higher values in all the mechanical tests. It was observed that the strength increases as the voids of the concrete reduces. The surface decoration with the polycarboxylate ether solution was observed as effective way of dispersion.